and 9.6. It's a vector equation of a plane. First part is the equation of a plane. We have three different forms of a equation of a plane, exactly like we had before the equation of a line. We have something called the vector equation of the plane. We have parametric equation. We have Cartesian. It's enough to have one of those three to get the other two. Case one, I will start by finding the vector equation of the plane, and then from it I will get the parametric and then the Cartesian. So given three non-collinear points. Again, I underlined here the non-collinear because if the lines are collinear, if the lines are on the same line, if the points, sorry, are on the same line, it doesn't form a plane. So 3 points should be non-collinear, so they can form a triangle, and this triangle will be the plane. So that's why the 3 points should be first non-collinear points. A 1 to 1, B 2 0 minus 1, and C3 minus 1 0. If I didn't mention non-collinear to prove that the vectors AB and AC are not collinear, I need to find the vector equation of the plane ABC. So first of all, if A, B, and C are in the same plane, if you take any point P of coordinates x, y, z that belongs to this plane, I can say that the vectors AP, AB, AC are coplanar. And the definition of coplanar vectors, I can write this relation between those vectors. So every time I need to prove that three vectors are coplanar, it's enough to prove that I can write the relation between those vectors. So all the time you take the point with the unknown is in the beginning. So I can write that AP is equal alpha AB plus beta AC, with alpha and beta belongs to R. We know how to find the coordinate of a vector, x of p minus x of a, the same. The coordinate of a, b, and ac, you can see here that they are not collinear. 2 over 1 is not equal to minus 3 over minus 2. And then I just write the equation. AP, it means x minus 1, y minus 2, z minus 1 is equal alpha AB, it means alpha times 1 minus 2 plus beta 2 minus 3 minus 1. And then to find the vector equation, I just need to write in form of x, y, z. So the minus 1 is going to be on the second side, plus 1, plus 2, and plus 1. And then this equation will be the vector equation of the plane ABC. So xyz is equal 1 to 1 plus alpha 1 minus 2 plus beta 2 minus 3 minus 1. Now to write the Cartesian equation, I just need to write as an equation. So I will write x is equal 1 plus alpha plus 2 beta, y is equal 2 plus minus 2 alpha plus minus 3 beta, and that is equal 1 minus 2 alpha minus 3 beta, or I can even write the constant in the end. So this is the Cartesian equation, the parametric, sorry. How are we going to find the Cartesian equation? Cartesian equation, it means we need to eliminate alpha and beta. I just need to focus on x, y, and z, and I need to find the equation in terms of x, y, and z. So you focus on, you take the first two and the second two, and then you focus on eliminating one of the variables, or alpha or beta. So here what I'm doing, I'm eliminating alpha. So I did 2 times the first equation plus the second equation to eliminate alpha. So I will have 2x plus y is equal to alpha minus 2 alpha is 0. 4 beta minus 3 beta and 2 plus 2. And then the first equation will be 2x plus y is equal beta plus 4. Now, then I took the second and the third. If you subtract, you will eliminate alpha. So I will have y minus z is equal minus 2 alpha plus 2 alpha 0, minus 3 beta minus beta, it means plus beta, it's minus 2 beta plus 1. Now I have two other equations with two unknown, xy, I have x, y, and y, z, but I need now to think about eliminating beta. And once I will eliminate beta, I will get the Cartesian equation. I will multiply the first equation by 2, and then I will add. So I will have 4x plus y plus 2y minus z is equal to 9, and then this is the Cartesian equation of the line. It's very simple, it's very easy. With the practice, guys, you will get it. It's not hard at all. Now, case 2, if I want just directly to find the Cartesian equation first. I don't want to pass through the parametric and the vector equation. So again, we know that AB and AC, they form a plane. and I just need the normal for this plane. And how do we find the normal vector? We know from the preceding lessons that to find the normal vector, we need to do the vector product of AB vector AC. So if I do AB vector AC, it gives me the normal vector minus 4, minus 3, 1. So if n is perpendicular to the plane, it means it's perpendicular to all the lines in this plane and specific to the vector AP. So it means I can do n dot AP is equal to 0. AP also is a vector from the preceding case. And then you do the dot product, x prime plus y prime plus z prime. So minus 4 times minus x minus 1. It's going to be minus 4x plus 4, minus 3y plus 6, and plus z minus 1 is equal to 0. And then we fix it, you will get the Cartesian equation. I can from it find the parametric, but it will not be sure the same. I don't have just a unique parametric equation, guys. I have many parametric equations because you can even here write, for example, BP is equal alpha BA plus beta BC. So I have many parametric equations, but it will give me all the time the same Cartesian equation. So to find the parametric equation, you can just easy say, for example, let x be lambda and y be beta, and then you will find you have x, y in terms of lambda, beta, and z in terms of the other two variables. So the parametric is not, it's not a unique equation. Now, part 2, we need to find the position of two planes. To study the position of two planes, we need to compare the normals of those planes. So, because each plane is defined by its normal. We know from the preceding lessons that a line is defined by its vector director, and here a plane is defined by its normal vector. So if the normal vector are collinear, so what does mean collinear? They are parallel. So if the normal vector are collinear, it means the planes are parallel or they are overlapping, because if I have this is one plane, this is another plane, those are parallel. Look at the normals, they are parallel, so the planes are parallel, but they could be also overlapping. How I will know that? So first you check if the vector director are parallel. If they are parallel, it means, sorry, the normals are parallel. If the normals are parallel or are collinear, it means the planes are either parallel or overlapping. So I need to take a point from one plane to check if it's in the other point. So if I have collinear normal and not a common point, so it means they are parallel. But if I have collinear normals but with a common point, it means the planes are overlapping. It means they are over each other. And if the vectors are non-collinear, the normal vectors non-collinear, it means the planes they intersect. And what is the intersection of two planes? We know that the intersection of two planes is always a line. Now, it's a remark. If the normals are perpendicular, it means the planes are perpendicular, because the normals, this is the first plane, this is its normal. The other normal is like this, the plane is like this, so I need the two planes are perpendicular. Let's do an example, guys. If I have those three planes, P1, P2, P3, I want to compare P2 and P3. It means I want to see if those planes are parallel, overlapping, or coinciding, or they meet. First, you need to find the normal of the plane. You know how to find the normal. The normal are the coefficient of x, y, and z. So the normal of P2 is 1, 2, minus 1. The normal of P3 is 2, 4, minus 2. How do we check if they are collinear? 2 over 1, it's the same as 4 over 2, it's the same as minus 2 over 1. Those are equal, it means the two vectors are collinear. It means either the planes are parallel or they are overlapping. How can I check if it's parallel or overlapping? Either you solve the system to see if there is a point of intersection, or you take any point on the line on the plane P1. For example, we say for x1, y1, you find what is z. You replace the point on the side. How do you take a point on a plane? You can pick any x and any y. I can say I want x1 and y1, and then you find for x1, y1 the value of z. So here, for example, z will be 3. So it means 113 is on this plane. And then I check if this point is here. Because if the planes are overlapping, it means any point on the first plane should be on the second plane. So I took this point 113. So that's it. It's the same here. So P2 and P3 are either parallel or overlapping. To check if overlapping, you can solve the system or take any point on P2 and check if it belongs to P3. I took this point and then I'm checking it. We replace it in P3 and I reach to the wrong answer. 0 equal 1. What does it mean? The planes are not overlapping, they are parallel. Another example, now I'm still in the same case. I need to study the position of the plane P1 and P2. So first of all, I find the normal, 2 minus 3, 5. Here the normals are 1, 2 minus 1. 1 or 2 over 1, it's not equal to minus 3 over 2. It means they are not collinear. Excellent. It means the plane they meet. So now I need to solve the system to find the line of intersection. How are we gonna solve the system? This is my system of equation. So to solve all the time, to find the, need to be careful, the equation of the line of intersection will not be y equal mx plus b. It's gonna be a line with x, y, and z. So either it's gonna be a parametric equation or it's gonna be a Cartesian, but the Cartesian equation in 3D is not one equation. It's x equals z equal to y. Now you will see how. All the time you take, for example, one of the values x or y is equal to a parameter. So I said here let x be t. And then I will have now, because here it's a system of two equations with three variables, impossible to find one solution. So I mean one equation of a line. So I have 2t minus 3y plus 5z is equal to 1. At t plus 2y minus z is equal to 0. Now I have a new system, y and z and t. Now my objective is to find either y, either t in terms of z. So I decide to eliminate z. So I will add the first equation plus 2 times 5. So I multiply the second equation by 5. So I will have minus 3y plus 10y plus 5z minus 5z is 0. 1 minus 2t minus 5t. And then I solve for y and I got y in terms of t. So I have x in terms of t, y in terms of t. Now I replace x and y in any of the equation, the first or the second, to find also z in terms of t. So this is x, this is y. In 2, I replaced z. Z is 2y plus t. So instead of y, I wrote minus t plus 1 over 7. And then I got z in terms of t. So this is the intersection. This is the equation of the intersection line between the two planes. I can also write it as this form. So how I can write it? I change this one. I can write t is equal. I take to the other side. It's 1 over 7 minus y. And here I can write t is equal to over 7 minus z. So either you write it like this or like this. And this is the equation of the intersection line of the two planes. Now the intersection of three planes is a little bit different. So the intersection of three planes, it could be either a line or a point, because three planes can meet at a line or at a point. At a point, it's very easy, guys. You solve the system of the three equations and you find x, y, and z. I will not do it. We will see it in the class. But I just want to make two examples for three planes, and when it's a line or when it's a point, but when you have a unknown. So given the three planes, I have P1, P2, and P3. And if you'll notice here, I have an unknown here in this third plane. Determine M so that the three planes intersect at a point. So when I say that the three planes intersect at a point, it means the intersection of those two planes should be the intersection of the third one. So what I need to do first? First, I will find the intersection between P1 and P2. So I will, and the intersection between the first two planes, I know that the intersection between the planes is a line. Okay, so let's find the intersection of those two planes. As I did before, I will replace x by t. I did in the preceding example, and then I will have two equations in terms of t. I will find y in terms of t, and I will find z in terms of t. I got y is equal 5t minus 16. And then I got x and y in terms of t. I will replace to find z in terms of t. And I got the line of intersection of those two planes. So I got the line of intersection between the first two planes. Now this line should intersect the plane P3 in one point. How gonna this line intersect this plane P3 in one point? So the line, so I can see here, the line can have any position except what? To be parallel or included in the plane, because the line should cut the other line in one point. So if this line is in the plane or it's perpendicular to the plane, it means it has or no intersection at all, or many intersections, because if the line is inside the plane, it has many intersections. And if this line is parallel, there is no intersection. So the line can have any position except to be parallel or included in the plane. What does it mean? So this line, that the third line that I need to find M for it, okay, cannot be parallel or included in the plane. It means N, the normal of the plane, can't be perpendicular to the direction vector of the line. So because each line has this a direction vector. So the direction vector of this line, the third line, and the normal cannot be perpendicular. So and then I do the dot product cannot be equal to 0. The normal vector of the plane that I have it, I can look here. It's 4m minus 4. And the direction vector here, I look at the coefficient. It's 1, 5 minus, uh, what I wrote here. Minus 1. This is minus t here. Minus 13 t. I forgot the t. Minus 13. And then I do the dot product, and m can be any value except minus 56 over 5. So I will repeat again. When I have three planes and I want to find a value for which those three planes they intersect at a point, you take the first two planes, those meet at a line. Okay, now I still have the line and the plane. This line can have, to meet, this line should meet the third plane in one point. So it means the line should have this position. To be able that this line just cut the plane in one point, it should be like a slant. So it cannot be parallel to the plane or in the plane. It means if it's parallel or in the plane, in both cases, the dot product of n times d will be 0. So I just do the case n dot d not equal to 0. Now the second case now that I'm doing, I have also three planes. I have the third plane, I have 4 unknown it, and I need to find A, B, and C so that A, B, C, and D, I forgot D, so that the three planes intersect in one line. So the intersection of those three planes should be one line. It's like the book. When you open the book, 3 pages, I'm trying to draw it like this, for example, the 3 pages will meet at a line. Step 1, also I find the intersection between the first two planes. It's a line. So I will solve it again. X equal to t, we did it already many times the preceding example. And then I have two systems, y and z in terms of t. Then I will isolate them to find y, x, and z in terms of t. I got this equation of a line. Excellent. So now this line is the intersection of P1 and P2. And this line must be in the plane P3. This line must be in the plane P3. Why? Because when I say the intersection of those three planes is a line, it means it's a common line. So the intersection of the two planes the first two planes as a line. This line should be also the intersection with the other plane. So to be the intersection with the other plane, so this line must be in the plane P3. What does mean that the line is in the plane? It means the vector director of this line and the normal of the plane are perpendicular. It means here I need to do that and but here and dot the vector director is equal to 0. So now I have the vector director of this line. It's 1, 3 over 2, 1. Okay. And the vector director of the plane that I don't know, it's A, B, C. You can choose any values of A, B, and C that so that n dot D is equal to 0. So I will take any value for A and C. For example, I took A1 and C1, and I will solve it equal to 0. So 1 times 1, 1, plus 3B over 2 plus 1 is equal to 0. And then you solve for B, and I got a value for B. Be careful, guys. I have many, many, many values of A, B, and C, not just 1. And now when I have A, B, and C, I still need, so this one will be the equation of the third plane, but I still need to find D. How do we find D? To find D, use any point on the line of intersection and replace it in P3. So this is the line of intersection. How I can find a point here? You can replace T by any value. T0, T1. I replace and I will have a point. I got the point 0, minus 16 over 5 and minus 6 over 5. And then I replace it to find the value of D. And then I got one of the, not the one plane. So the equation of one possible plane is x minus 4 over 3y plus z equal 46 over 15, or I can multiply it by 15. So I cannot have just a unique plane. You can have many planes. So here I have one, I got one possible plane. Sorry guys, the video is a little bit long, but take your time watching it and see you in the next video.